For 321 days, NASA heard nothing. Not silence exactly, just a single quiet beep. Once a week. From a spacecraft so far from home that its own radio signal needs almost 9 hours just to cross the distance between it and us. Then, on June 23rd, 2026, something changed. A signal came in. Not a beep this time. A full status report. Complete. Detailed. Alive. NASA's New Horizons, the spacecraft that gave humanity its first ever look at Pluto, had just woken up. Nearly 6 billion miles from Earth. Farther than Pluto. Farther than almost anything humans have ever built has gone. And the moment it opened its eyes again, it started sending back something it had been collecting the entire time it was supposed to be asleep. The question every scientist at Johns Hopkins is asking right now is simple. What was it listening to out there, in the dark, for almost a year, while nobody on Earth was watching? Let's find out. To really appreciate what just happened, picture this. A machine the size of a grand piano, built by human hands 2 decades ago, has been drifting through total darkness for so long that the sun itself is now just another bright star in its rearview mirror. No repair crew, no backup plan, no way to fix a single loose wire if something goes wrong. And for nearly a year, that machine was completely on its own, trusted to do exactly what it was told, exactly when it was told to do it. Before we get to what New Horizons found, you need to understand exactly how far away out there really is. Because the number sounds big, it is not big enough to describe it. New Horizons is currently about 5.9 billion miles from Earth. That's 9.5 billion kilometers. In astronomical terms, that's 64 astronomical units, 64 times the distance between the Earth and the Sun. Let's put that in perspective using something we all understand, light. Light from the Sun takes about 8 minutes to reach Earth. That same light, if it kept traveling outward, would take another 8 hours before it reached New Horizons. Right now, if you wanted to send a text message to this spacecraft, it would take almost 9 hours to arrive, and then another 9 hours for the reply to come back. A single hello and hello back would eat up nearly a full day. This isn't a satellite orbiting Earth. This isn't even a probe circling Mars. New Horizons is in the Kuiper Belt, a vast, frozen ring of ancient debris that begins past Neptune and stretches out into the darkness at the edge of our solar system. It's a region so remote that only a handful of spacecraft in human history have ever passed through it, and only 2 have gone beyond it entirely, Voyager 1 and Voyager 2. To put the scale of this place in perspective, imagine shrinking the entire solar system down until the Sun is the size of a basketball. On that scale, Earth would be a grain of sand sitting about 30 meters away. Pluto would be another speck of dust, roughly a football field further out. And New Horizons, right now, would be sitting even beyond that, drifting through a region so thin and so cold that entire decades can pass with almost nothing happening out there except the slow, silent drift of ancient icy fragments left over from the birth of the planets. To understand why New Horizons went quiet for 321 days in the first place, you need to understand how spacecraft survive out here. There's no cell tower, no Wi-Fi, no mission control constantly holding your hand. Out past Pluto, sunlight is so weak that solar panels are essentially useless, which is why New Horizons runs on a nuclear battery, a radioisotope thermoelectric generator that slowly converts the heat of decaying plutonium into electricity. And because commands take hours to arrive and hours to confirm, NASA can't micromanage this spacecraft in real time. So during long, uneventful stretches of the journey, mission controllers do something that sounds almost eerie. They tell the spacecraft to go to sleep. They call it hibernation. It's a strange word to use for a machine, but it fits better than you'd think. Just like an animal conserving energy through a long winter, New Horizons shuts down almost everything that isn't essential to survival. Heaters stay on just enough to keep sensitive electronics from freezing solid in temperatures that can drop to nearly 400 degrees below 0 Fahrenheit. The onboard computer keeps a quiet internal clock ticking. And the spacecraft simply waits, drifting through the dark at roughly 34,000 miles per hour, doing nothing except staying alive and counting down the days until it's told to wake up again. On August 7th, 2025, NASA sent New Horizons a set of commands. Not commands to do something, commands to stop doing almost everything. Power down the non-essential systems, reduce communication to a bare minimum, keep only the scientific instruments alive, quietly gathering data in the background. And then, on a specific date, nearly a year later, wake yourself back up. This wasn't the first time New Horizons had hibernated, but at 321 days, this was the longest hibernation period in the spacecraft's entire 20-year history. Here's the part that should genuinely unsettle you. For those 321 days, NASA didn't talk to it at all. No commands were sent, no data was pulled down. The only thing that came back to Earth was a single automated beacon signal once a week, just to confirm the spacecraft was still functioning. Not what it had seen, not what it had measured, just a heartbeat, a pulse, proof of life, and nothing more. Meanwhile, in the background, New Horizons never actually stopped working. Its heliospheric plasma sensors kept recording. Its Pluto energetic particle spectrometer, an instrument built to detect charged particles from deep space, kept measuring. Even its dust counter, a device named after Venetia Burney, the 11-year-old British girl who named Pluto back in 1930, kept quietly counting particles of interstellar dust drifting past the spacecraft's hull. For 321 days, this machine, alone, 6 billion miles from the nearest human being, was recording the universe around it, and no one back home had any idea what it was picking up. Then came June 23rd. At the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland, flight controllers Mark Lahr and Josh Albers sat at their consoles waiting. The wake-up command had been preloaded into the spacecraft's computer nearly a year earlier. This wasn't a live decision. It was a promise New Horizons had made to itself, buried deep in its code, to be kept exactly on schedule. And it kept that promise. Mission Operations Manager Alice Bowman later described it simply. Every status report through this hibernation period was green, meaning all was well aboard New Horizons each and every week. Green, the color of confirmation, of survival, of a machine that had done exactly what it was told, exactly on time, across a distance almost too large to comprehend. The confirmation signal took 8 hours and 52 minutes to travel from the spacecraft to the Deep Space Network antenna near Madrid, Spain, and then on to mission control. Nearly 9 hours between I'm awake and humans finding out about it. New Horizons was alive, and now it was ready to talk. For the flight controllers who had waited nearly a year for that moment, it wasn't just relief, it was validation. Every calculation about power reserves, every line of code written to trigger at exactly the right instant, every assumption about how the spacecraft's aging systems would hold up in that much cold and that much isolation, all of it had just been tested against reality, 6 billion miles away, with no chance for a do-over if something had gone wrong. Here's where the story gets bigger than just a spacecraft woke up. Because New Horizons isn't some forgotten piece of hardware drifting aimlessly. It's positioned exactly where scientists need it to be, at exactly the moment they need it there. Rewind to January 2006. NASA launches New Horizons atop an Atlas V rocket, and it leaves Earth faster than any spacecraft before or since, fast enough that it passed the Moon's orbit in just 9 hours, a trip that took the Apollo astronauts 3 days. In February 2007, it swings past Jupiter using the giant planet's gravity like a slingshot to add extra speed to its journey, while its cameras capture some of the most detailed images ever taken of Jupiter's turbulent atmosphere and its moons. Then, on July 14, 2015, almost exactly 11 years before the events we're covering today, New Horizons does something no spacecraft in human history had ever done. It flies past Pluto. For decades, Pluto had been a blurry smudge of pixels, even through our most powerful telescopes. New Horizons changed that in a single flyby. It revealed a world nobody expected, towering mountains made of water ice, vast glaciers of frozen nitrogen shaped like a heart, and a thin, hazy blue atmosphere that shouldn't have looked as beautiful as it did. Pluto went from a distant dot to a real, complicated, geologically active world in the space of one close pass. But New Horizons didn't stop there. In January 2019, it flew past an even more distant object, Arrokoth, a strange, reddish, snowman-shaped body in the Kuiper Belt, and the most distant object any spacecraft has ever explored up close. Arrokoth is basically a fossil, a frozen relic from the earliest days of the solar system's formation, 4.5 billion years ago, preserved almost perfectly because it's been sitting in the deep freeze of the outer solar system this entire time. Since then, New Horizons has kept moving outward at a staggering 300 million miles per year, studying dozens of other Kuiper Belt objects from a distance, and slowly approaching one of the most mysterious boundaries in the entire solar system, the heliopause. This is the point where the sun's influence effectively ends, where the solar wind, the constant stream of charged particles blasting outward from the sun, finally runs out of strength and collides with the interstellar medium, the thin soup of matter that fills the space between star systems. Only 2 human-made objects have ever crossed this boundary and confirmed it: Voyager 1, which crossed it in 2012, and Voyager 2, which crossed it in 2018. Both are now technically in interstellar space, further away than New Horizons. Voyager 1 alone is roughly 173 astronomical units out, nearly 3 times farther than New Horizons currently is. But here's the twist that makes New Horizons special, and honestly, more valuable than either aging Voyager probe right now. The Voyagers were built in the 1970s. Their instruments are primitive by comparison. New Horizons was built decades later with far more sensitive equipment specifically designed to study exactly this kind of boundary region. As New Horizons project scientist Pontus Brandt put it, the data from studying this termination shock region will be a treasure trove for space physicists worldwide who are eager to understand how this vast boundary works. He added something that should stick with you. All these discoveries from pioneering missions like Voyager and New Horizons teach us how little we know about what lies beyond. That's not a throwaway line. That's a scientist, standing at the edge of our knowledge, admitting that even after 50 years of deep space exploration, we still don't really understand the wall between our solar system and the rest of the galaxy. New Horizons might be the spacecraft that finally does. And unlike the Voyagers, which are slowly losing instruments as their own power fades year by year, New Horizons is entering this critical stretch of its journey with nearly all of its science instruments still fully functional. That matters more than it might sound like. It means that whatever data comes back from the heliopause, whenever New Horizons finally gets close enough to study it in detail, it will come from a full suite of modern instruments working together, not from a handful of aging sensors limping along on borrowed time. So what did it collect during those 321 silent days? Now that New Horizons is awake, mission controllers are downloading the data in careful stages, starting with basic spacecraft health information, then moving on to actual science data. It's not instantaneous. At this distance, even simple file transfers take patience most of us can't imagine. 3 instruments were quietly working the entire time. First, the heliospheric plasma sensors, part of an instrument called SWAP, Solar Wind Around Pluto, which measures the charged particles streaming out from the sun. Out here at the far edge of the solar system, the solar wind has been slowing and thinning for billions of miles. Understanding exactly how it behaves this far out helps scientists map the true size and shape of our entire solar system's protective bubble, called the heliosphere. Second, the Pluto energetic particle. Spectrometer, science investigation, a mouthful of a name for an instrument that detects high-energy particles, some of which may originate from other stars entirely, or even from cosmic rays that have traveled across the galaxy before reaching this remote corner of space. Third, the Venetia Burney Student Dust Counter, which spent 321 days counting individual grains of interstellar dust colliding with the spacecraft. Every single tiny impact is data, a tiny fingerprint of material that may have drifted in from beyond our solar system entirely, giving scientists clues about the composition of the space between stars. In about 3 weeks from its wake-up, New Horizons will also point its onboard ALICE ultraviolet spectrograph at the surrounding space to study how hydrogen gas is distributed in the outer heliosphere, essentially mapping an invisible, glowing structure that exists in the space around us, made of gas so thin it would be undetectable to the human eye, but which tells scientists exactly where our solar system's influence fades into true interstellar space. None of this is a single dramatic reveal. There's no photograph of an alien signal, no monolith, no smoking gun. But that's not really the point. The point is this. For nearly a year, humanity had a functioning scientific outpost sitting at one of the most remote and least understood frontiers in the entire solar system, recording data the entire time. And we are only now starting to find out what it heard. And this is just the beginning of the download. Scientists expect the full data set from these 321 days to take weeks to fully retrieve and even longer to properly analyze. Every data packet has to be requested, transmitted across billions of miles, verified, and cross-checked before anyone can say with confidence what it actually means. So while the headlines today are about the wake-up itself, the real story, the actual discoveries hidden inside that data, is still unfolding right now, one careful transmission at a time. Here's where the story turns from wonder into urgency. New Horizons runs on that radioisotope thermoelectric generator we mentioned earlier, essentially a nuclear battery fueled by decaying plutonium-238. And like any battery, it doesn't last forever. It gets weaker year after year as the plutonium fuel naturally decays. This isn't a spacecraft that can be repaired, refueled, or upgraded. Once it launched in 2006, its power supply was fixed. Every year that passes, it has slightly less electricity to run its instruments, its heaters, and its communication systems, which means every hibernation decision, every choice about which instruments to run and which to power down, is really a decision about how to spend a resource that can never be replenished. NASA has already extended the mission through New Horizons' full journey out of the Kuiper Belt, which is expected to continue until roughly 2028 to 2029. But even that isn't necessarily the end. Mission planners have discussed continuing observations of the heliosphere and even deep space astrophysics beyond that point, as long as there's enough power left, and as long as NASA continues funding the mission. Some of the more optimistic projections suggest New Horizons could keep sending back valuable data into the late 2030s, meaning this single spacecraft, launched when smartphones didn't exist yet, could still be exploring the literal edge of our solar system more than 3 decades after liftoff. But there's a sobering truth underneath all of this. Every hibernation period like the one we just witnessed is also a strategic trade-off, a way of conserving that irreplaceable power so the spacecraft can survive long enough to reach the most scientifically valuable region of its journey, the heliopause itself, the true boundary between our solar system and interstellar space. New Horizons might be humanity's best chance at getting fresh, modern, high-quality data from that boundary, using instruments the Voyager probes simply didn't have, but only if its aging power source holds out long enough to get there. Every wake-up, from now on, carries just a little more weight than the last. That's part of why NASA is so deliberate about every hibernation cycle. Each one is carefully modeled in advance, weighing exactly how much power will be saved against exactly how much science might be missed by going quiet. It's a balancing act played out across years, not days, by a small team of engineers who understand that they may only get one real shot at capturing high-quality data from the true edge of the solar system. And that shot depends entirely on decisions being made right now, with a battery that only gets weaker with time. So why should any of this matter to you, sitting on Earth in 2026? Because right now, in this exact moment, there is a piece of human-made machinery, farther from home than almost anything we've ever built, quietly measuring the invisible structure of the space around our entire solar system. It's mapping the edge of the bubble that protects every planet, every moon, every living thing in our cosmic neighborhood from the harsh radiation of interstellar space. We are, for the first time in history, building an actual map of where home ends and the rest of the galaxy begins. Not from theory, not from computer models, from real instruments physically sitting in that boundary region, sending back real numbers. And we're doing it with a machine that had to survive completely alone in the coldest and darkest place humans have ever sent a functioning spacecraft, trusting a set of commands written nearly a year in advance to wake it up on exactly the right day, at exactly the right moment, without a single human being there to check on it. Think about that the next time your phone loses signal for 5 minutes and it feels like the end of the world. 6 billion miles away, a spacecraft just spent 321 days completely alone, in the dark, near absolute zero, and woke itself up right on schedule, carrying a year's worth of secrets about the true edge of our solar system. We don't have all the answers yet. The data is still coming in, byte by byte, across 9 hours of empty space. But every single transmission that arrives from New Horizons over the coming weeks and months could reshape what we know about the boundary between our solar system and the rest of the universe. And Cosmic Vault will be here, breaking down every single discovery as it happens. New Horizons proved something remarkable this week. That even 6 billion miles from Earth, in total darkness, completely alone, humanity's machines can still keep their promises. If this video opened your eyes to just how vast and how alive the edge of our solar system really is, hit subscribe and turn on notifications. Because New Horizons is about to start sending back a year's worth of secrets from the edge of everything we know. What do you think it recorded out there in the dark? Let me know in the comments below. This is Cosmic Vault. And the universe just got a little bit closer.